Hello everyone, how are you all? Welcome back to your physics online session. For now today, continuing with our chapter number 6, we will begin with our topic poles of a magnet. That is on page number 60. But before that, let us first of all revise and see what we did in our last class. In our last class, we discussed about magnets and types of magnets, then shapes of magnets, and magnetic and non-magnetic substances. Now, finally, I managed to get a compass just to show you and bar magnets. Let us first of all see the working of a compass. Now see students, the needle in this compass, although it is very small, but we can still try to just see in it that the needle of this compass is lying towards north and south. Yes, this is north over here and this is south over here. Okay, so this is how the principle of magnetism works for the compass. The whenever we set the compass in rest position or the needle of the compass in see, even when I'll just move it, it should come to north and south direction. See, it is north over here and this is south. I hope you all can see S written down over here. So automatically it will take its place. Okay, now we will come back to our bar magnets. See, it's S written down over here and N over here. It means over this towards this side it is S and towards this side it's north. Similarly, on this bar magnet also S and N. Now, according to the principle, only when we will bring S and N together, it will attract. See, right? They both are attracted towards each other. But now, when we will, I'll just change the direction. Now, both the sides are north and north. We will see it will not attract. See, it did not get attached to each other, so it means they are repelling each other. Okay, so this is how the principle of magnetism works on magnets. Okay, so now let us get back to now let us read and understand what are like poles of a magnet. Spread some iron fillings on a drawing sheet. Place a bar magnet on it. Slightly shake the paper so that the iron fillings stick to the magnet. What do you observe? Do the iron fillings cling all over the magnet uniformly? You will observe that more fillings more cling to the magnet near its ends and near its middle. Now see students, what we exactly need to do in this activity is like we need to just place a magnet, okay, and iron fillings means in Hindi let me tell keel, okay, keel jo that we used to use, okay. So we need to just keep so many iron fillings over here. Then what will happen when we will place a bar magnet over here? The iron flings will get attracted towards this side and this side, okay. The more and more flings will be attracted towards these ends, not in the middle, okay. Draw a figure of the way iron flings cling to various portions of the magnet. So actually like what they are trying to show us is more the way the iron fillings will come and attracted towards this bar magnet will be will like this, okay. More will be over these two ends and less will be on this middle part. We find that more flings cling to the ends of the magnet than to its center. Yes, okay. This shows that the attraction of the magnet is strongest at the two ends than in the middle. Yes, so more attraction always lies on the ends than in the middle. The ends of the magnet where maximum iron fillings get clung, the attraction is strongest, are known as poles. The two poles are called North Pole and South Pole. So the ends have the maximum iron fillings clung. It means the ends have the maximum attraction point. Okay, and these two ends are also called as this side is called as North Pole and this side is called as South Pole. Both poles are equally strong and both these poles are equally strong. Now this property of magnet can be used to identify a magnet when two identical pieces of iron are given to you. Suppose you are given two identical bars which look as if they might be made up of iron. One of them is a magnet while another is a simple iron bar. How will you find out which is which? We will place one of the pieces vertically to the other horizontally. We will slide the vertical iron over the horizontal piece. If the attraction is same everywhere, then the vertical piece is a magnet, and if the attraction is maximum at the ends and minimum in the middle, then piece lying horizontal is a magnet. Okay, so another observation they are asking us to do is to place two magnets. Okay, identical exactly same magnets in front of each other, and one is made up of iron and one of them is a magnet, while the other one is a simple bar. Okay, simple iron bar. How will you find out which is which? Now we need to check whether like two bars, one is a magnet and one is a iron bar, and they both look exactly same. Now what we need to do, we need to check or we need to come to know that which one is the iron bar and which one is a magnet. So what they have asked us to do, place them, one of the pieces place it vertically and another one horizontally. Then we will slide the vertical piece of iron over the horizontal piece. If the attraction is same everywhere, then the vertical piece is a magnet, and if the attraction is maximum at the ends and the minimum in the middle, then the lying horizontal is a magnet. Okay, so this is how we can come to know like whether a piece is a magnet or not, because if anything is a magnet, then the maximum attraction would be to on the ends, on south end or north end. Okay, now we will see characteristics of a magnet. The basic characteristics of magnets are known to every child who has come across a fridge magnet. Magnets snap to objects made up of out of iron, and they either snap to each other or repel. The feeling of the attraction or repulsion is easy to describe and detect, but what is it that creates this behavior? Some of the magnets characteristics of magnets are, yes, characteristics like basic characteristics, we all know that magnet either attract iron or like copper or like magnetic substances, or they repel. Okay, either they attract or they repel. And the basic example is our fridge magnets. Like each refrigerator is having a magnet in it, especially on the doors. Right, now we'll see some of the characteristics. Two magnets interact. If you take two magnets and try to push them together, they will either attract or repel. This one we have already seen. There is a magnetic force between the magnets that can even be felt by your hand. The reason for this behavior is that each magnet has a north and a south pole. When the north pole of one magnet is subjected to the north pole of another magnet, the two magnets will naturally repel each other. We learned from this that magnets have the characteristics of opposites that attract and likes that repel. Yes, obviously we have seen that this is south and this is north, and these two are opposite, and even then they attracted each other, right? But when likes means both the sides are of south, they both are same, but even then they repel each other, right? Then second point is magnets have memory. You can make a simple test with an LCD calculator to see how magnets have memory. Take a permanent magnet and place it next to the screen of your calculator. You should first have entered a number there. You remove the magnet and return the calculator to 0. When you bring the magnet back, the same number as before will appear again because it was memorized by the magnet. This characteristic of magnets is used in credit cards where the magnetic strap of the card hold the sensitive information of our bank details. Yes, so this is also again a property of a magnet that is being used in our credit cards, or like in our ATM cards I should say, where I hope you all have seen the strip of the that is there behind our ATM cards or credit cards. So that strip is somehow made up of a magnet. That is the only reason how, like in ATM machines, we can easily insert our ATM cards, right? So due to that magnetic property only, they just take in our cards and they just read the bank details, and then they just do the proceedings. Okay, then say another property is magnetic fields. Magnets create magnetic fields that are both protective and stimulating. These magnetic fields can be used for many things, and one very popular area of use is magnetic therapy. Magnetic therapy lets the magnetic field of the magnet interact with the blood of the human body. By stimulating the blood circulation, the person being treated experiences pain relief and cure of many different ailments. This is also what makes magnetic jewelry an option for better health and well-being. So yes, magnetic therapy or magnets are also used for uh, or in therapies where it interact with the blood of a human body, and then by stimulating the body circulation blood circulation, the person being treated experience relief in their pain and cure of many different problems. And there are many magnetic jewelry also that people use for their better health. Then another property is split a magnet in two. Magnets will always have two poles, and even if you split a magnet in two, you can't get rid of the characteristic. Now see what they have done. They took a bar magnet, okay, and as I have already showed it to you, south and north. Now what will happen when I will just break this bar magnet? Yes. Another part, like when it will be, when I'll break it into two pieces, this corner will remain south, but then this part, if I'll break it from here, this part will become north, and then this end will again become south, and this part will remain north, as you all can see over here. Then again, if I'll break this part into two parts, then this end will become south and then north, then again this one south and this one north, then again this south, north, south and north. So it means even after breaking or splitting the magnets, the property will remain the same. Okay, the smaller piece will have two poles, and this will continue no matter how many splits you make. There are magnets where the poles are set to the same side, but these still include two poles. For magnetic therapy and healing purposes, the permanent magnets with two opposite poles are to recommend since they are the most effective. So especially all the ones who do magnetic therapy, what they used to do, they used to use permanent magnets with two opposite poles. Okay, so this is how they used to treat patients using magnetic therapies. Now, in our next class, we will discuss and learn about properties of magnets. Okay. Meanwhile, what you need to do, please read these two topics properly and carefully. Okay. And that is all for today. Have a good day, students. Take care.